Somewhere over Eastern Europe, a battalion-sized force is preparing to advance. The commander is receiving real-time intelligence from drones overhead. Artillery batteries are coordinating fires through secure data links. Air defense operators are tracking multiple contacts on networked radar displays. Orders are flowing from division headquarters through encrypted channels. The entire operation is synchronized, digital, dependent on a web of communication systems that connect every unit, every sensor, every weapon into a single coordinated force. Then everything stops working. Radar screens flicker and go blank. Radio channels fill with static. Data links drop. The drones lose connection and enter fail-safe mode, circling aimlessly. Artillery fire missions can't be transmitted. The commander tries to reach higher headquarters. Nothing. He switches frequencies. Still nothing. His air defense systems, which were tracking dozens of aircraft moments ago, are now operating blind, unable to share tracks, unable to coordinate, unable to engage. The entire battalion, moments ago a networked fighting force, is now a collection of isolated units with no shared picture, no orders, and no way to coordinate. They don't know it yet, but they've already lost. Modern militaries don't just carry weapons. They carry networks, command systems, communication architectures, data links that tie aircraft to ground forces, sensors to shooters, intelligence to operations. Take away the network, and the most advanced military in the world becomes a disorganized collection of platforms that can't see, can't talk, and can't coordinate. The aircraft responsible for creating that failure is already gone, operating from outside visual range, invisible on radar, silently dismantling the digital infrastructure that modern warfare depends on. It's called the EA-37B Compass Call, and it may be the most strategically consequential aircraft the United States operates. The EA-37B is an electronic attack platform. Its mission is not to drop bombs or fire missiles. Its mission is to disrupt, degrade, and destroy adversary communications and command networks using electromagnetic energy. It jams radios. It corrupts data links. It overwhelms air defense radar with false signals. It creates blind spots, communication voids, and decision-making paralysis across entire battle spaces. And it does this from distances where the adversary often doesn't know the aircraft is even there. This isn't new technology. The concept of electronic warfare has existed for decades. But what's changed is the degree to which modern militaries are dependent on networked systems. A tank from 1980 could fight without radios if it had to. A modern tank without data links, GPS, and communication is nearly useless. The crew can still fire, but they have no situational awareness, no shared targeting data, no coordination with adjacent units. They're isolated. And isolated units in modern combat don't survive long. The EA-37B exploits that dependency. It's not about destroying equipment. It's about severing the connections that make equipment effective. The tank still works. The radar still functions. The drone is still flying. But none of them can communicate with each other, and without that communication, their effectiveness drops to a fraction of what it should be. That degradation is strategic, not just tactical, and the implications ripple across the entire fight. Air defense systems are the first to collapse when communications fail. Modern integrated air defense networks rely on multiple radars operating in coordination. One radar detects a contact, another tracks it, a third provides targeting data. Fire control systems process inputs from all of them simultaneously and assign the optimal weapon to engage. This coordination happens in seconds, automatically, through data links that connect every node in the network. If those data links are disrupted, the network fragments. Each radar operates in isolation. Redundancy disappears. Coverage gaps appear. An aircraft that would have been detected, tracked, and engaged can now operate in spaces where the air defense system is effectively blind. The EA-37B creates those gaps. It doesn't destroy the radars, it doesn't need to. It jams the communication links between them. The radars are still scanning, but they can't share what they see. The fire control system that was coordinating the entire network is now receiving incomplete or corrupted data. Engagements that should be automatic now require manual coordination, which takes time, creates errors, and reduces effectiveness. And in air combat, time is survival. The strike package that was supposed to be intercepted is already through. Air defenses that can't communicate are air defenses that can't defend. And that's where things become irreversible. Drone operations collapse even faster. Unmanned systems, whether they're intelligence drones, strike drones, or loitering munitions, depend entirely on communication. They receive orders through datalinks. They transmit sensor feeds through datalinks. If they lose connection, most drones are programmed to return to base or enter a holding pattern. They don't continue the mission. They don't adapt. They just stop being useful. The EA-37B can sever those connections across wide areas. A swarm of drones that was coordinating autonomously suddenly loses the ability to communicate with each other or with ground control. The swarm becomes individuals. Coordination disappears. The tactical advantage of mass, the ability to overwhelm defenses through sheer numbers, evaporates. What was a coherent threat becomes a collection of isolated platforms, easier to track, easier to engage, easier to defeat. This applies to adversary drones and, in contested electromagnetic environments, to friendly systems as well. Electronic warfare is not a one-way street. Both sides are trying to disrupt the other's communications while protecting their own. The side with better electronic attack capabilities, more sophisticated jamming, and more resilient communication architectures has the advantage. And right now, the EA-37B represents one of the most advanced electronic attack platforms in operation. But that's only the beginning. Command chains break when orders can't flow. Military operations are built on centralized planning and decentralized execution. Commanders at higher echelons develop the plan. Lower echelon units execute based on their assigned objectives and commander's intent. That execution depends on continuous communication, updates, changes to the plan, coordination with adjacent units. All of this requires reliable communication links. When those links are severed, units revert to the last order they received and operate based on their own judgment. Sometimes that works. Often it doesn't. The EA-37B Compass Call is a strategic electronic warfare aircraft developed for the U.S. Air Force to provide advanced electronic attack capabilities. It is based on the Gulfstream G550 commercial business jet and is designed to replace the aging EC-130H Compass Call fleet. The EA-37B's mission is to disrupt enemy command and control communications, radars, and navigation systems, thereby hindering adversary coordination and suppressing air defense networks. This next-generation platform is crucial for maintaining military advantage in the electromagnetic battlespace. The EA-37B represents a significant leap forward in electronic warfare platforms compared to its predecessor, the EC-130H. The EA-37B utilizes the Gulfstream G550 conformal airborne early warning aircraft airframe, a derivative of the G550 business jet. In contrast, the EC-130H is based on the Lockheed C-130 Hercules, a mid-sized 4-turboprop engine military transport aircraft. The G550 airframe offers superior performance characteristics, including increased speed, higher altitude operations, and longer range. The EA-37B can achieve a speed of Mach 0.82, has a range of 4,410 nautical miles, and a service ceiling of 45,000 feet. The EC-130H was limited to a ceiling of 25,000 feet and a speed of 300 knots. Operating costs and weight. The EA-37B boasts a 50% reduction in weight and operating costs compared to the EC-130H. Its weight is 48,300 pounds, with a maximum takeoff weight of 91,000 pounds. The EA-37B is integrated with the modern Compass Call airborne tactical weapon system, which provides high mission effectiveness and survivability. This system incorporates BAE Systems' small adaptive bank of electronic resources technology, which transitions the earlier hardware-based EW system into a software-based electromagnetic spectrum warfare capability. Saber's open architecture allows for future upgrades without major reconfiguration. While many of its systems are ported over from the EC-130H, the EA-37B's advanced flight deck, modern electronics, and communications suite enhance its capabilities. The EA-37B accommodates 2 pilots and a crew of up to 7. The USAF plans to acquire 10 EA-37B Compass Call aircraft to replace the 14 aircraft EC-130H fleet. The first EA-37B was delivered to the USAF in September 2023 for testing, and the initial operating capability is expected in 2026. The aircraft will be operated by the 55th Electronic Combat Group at Davis-Monthan Air Force Base. Electronic warfare, as exemplified by the EA-37B, operates on the principle of disruption rather than physical destruction, offering a significant strategic advantage in modern conflict. The EA-37B's primary role includes disrupting enemy command and control communications. By preventing the transmission of essential information between adversaries, weapon systems, and command and control networks, it can effectively create communication blackouts. This capability can hinder an adversary's ability to coordinate forces, launch attacks, and respond to threats, effectively isolating their command structure without firing a single kinetic weapon. Electronic warfare plays a crucial role in pre-kinetic battlefield shaping, where the electromagnetic spectrum is manipulated to gain an advantage before physical engagements begin. The EA-37B can suppress enemy air defenses by jamming radars and disrupting the connection between their weapon systems and control networks. This allows friendly forces to operate with greater freedom and reduced risk. By degrading an adversary's ability to detect and track threats, the EA-37B contributes to establishing air superiority and enabling follow-on kinetic strikes. Beyond jamming, the EA-37B is capable of offensive counter-information operations. This can involve manipulating or deceiving enemy systems and potentially even hacking into wireless devices to gather intelligence or plant false information. Disruption through electronic warfare can achieve military objectives with a lower risk of casualties and collateral damage compared to kinetic attacks. It offers a cost-effective method to neutralize high-value targets. Modern warfare is increasingly reliant on the electromagnetic spectrum, making electronic warfare critical for success. The EA-37B's advanced capabilities, including real-time disruptive and adaptive jamming, are designed to counter sophisticated electronic threats and maintain a technological edge against near-peer adversaries. This includes addressing challenges like spectrum congestion and cybersecurity vulnerabilities. Electronic warfare, spearheaded by platforms like the EA-37B Compass Call, has transformed into a foundational element of modern military strategy. It represents the clash of invisible forces that can determine the outcome of conflicts even before the first physical shot is fired. The ability to control and exploit the electromagnetic spectrum by disrupting enemy communications, blinding their sensors, and protecting friendly systems provides a decisive advantage. In an age where battles rely heavily on interconnected technologies, EW ensures information superiority, enabling forces to outmaneuver adversaries and achieve objectives through non-kinetic means. This strategic focus on disruption underscores the evolving nature of warfare, where technological prowess in the electromagnetic domain is paramount for achieving and maintaining military dominance.